Okay, so this week in safety class, this is actually week number 6. I'll change that here. Week 6. There we go. So this week we are talking about Lockout Tag Out. There we go. So here is the question we are asking for this. My drawing pad going here. Okay, my question here is there somebody working in this big drum thing here? Are you okay to go and shut this door and start this machine up because you know that there is nobody working in here? Yes or no? So this is the whole idea behind Lockout Tag Out, is because the answer to that is you don't know. Okay, you can't really tell if there is somebody in there or not. All right, so because of that, you can't tell if it's okay to shut this door and start it up, or if you're going to be endangering somebody by doing that. So that is the idea behind our Lockout Tag Out procedure that people have come up with. So what is lockout? It's basically a procedure that we follow through on to ensure that we do not put ourselves or our coworkers in danger by basically putting a safety lock, which is physically a padlock, by putting that on a lockable device. You have the key for this, and we basically shut off a machine, put a lock on it, and make it so no one else is capable of turning that machine on except for you. Okay, so in this case here, a guy like Lenny over here shuts off this big fan at this switch, and Homer is not able to come over and turn it on behind him. Alright, so Lockout Tag Out, or LOTO as we will use the acronym for it, we're going to say it's an effective procedure to prevent the unintentional release of energy. So we're actually controlling energy and various forms of energy when we do this. Placement of a lock and a tag on an energy isolating device in accordance with an established procedure, indicating that the energy isolating device is not to be operated until removal of the lock or tag in accordance with established procedure. Okay, so why is this important? 3 main points. Number 1, reduce contact with the hazard while performing the task that requires removal, bypassing or deactivating safeguarding devices. So basically, if, let's say, you are going to be changing the, let's do this as just a rough example here. Let's say you have a table saw and you have a blade on your table saw, and you're going to change that blade, and you've got a switch here, and it plugs into the wall. A couple things you could do if you're going to change that blade: you want to make sure this never accidentally starts while you're doing this, okay, while you're putting your hands on this jagged blade and changing it. So the first thing you're going to do, you're going to be removing the guard that goes around this. So anytime you're doing that, you're creating a further unsafe situation. So we're talking about here removing or deactivation of safeguarding devices. So if we're doing this, we want to lock this out. So we're definitely going to unplug the table saw, and then we can put some other device around this so that this can't actually be plugged in again. And we could put our padlock on this. We can also put some type of a locking device around this so that someone can't turn the switch on These are all different things that could be done to lock this machine out. Okay? So stop the unintended release of stored energy. So what is stored energy? This could be anything such as, when we talk about stored energy, we've got heat, gravity, things like springs, anything like that that actually is an energy storing device. There's a couple electrical things you can do for this as well. Capacitors. These are all devices that store energy. So for example, let's say you have some type of slide that moves up and down and you need to work underneath it. Some type of lift. What you might do if you need to work in that area and you want to prevent this thing from falling, you might have some type of a block that you place in here that prevents this from being capable of falling. Or you might have some type of pin that goes in here and locks this thing in place and prevents that from being able to move. Okay, these would all be different types of devices you could put in here to basically control gravity. Alright, so that is stop unintended release of stored energy. And then the final one here, stop unintended startup. This is kind of like this example here with the stopping the switch. We talked about this one here. Actually taking away that start switch. So locking out that starting switch so that someone can't accidentally start the machine back up again accidentally. So energy sources including electrical, mechanical, hydraulic, pneumatic, chemical, thermal, and other sources. Can be hazardous, barrier guards or guarding devices, engineering controls, safeguarding technology. Remember, these are engineering controls. Are installed in on systems to maintain worker safety while these systems are in operation, but we are probably removing these when we are doing maintenance. So lockout tag out is a maintenance function. We should point of that. Let's look at this little video here. This is, I think I showed this video last week, or parts of it. Let's think about all the different types of energy that are in here. So these are aluminum castings being cut in a big saw. So let's think about everything that's going on in here. If you were going to lock out and work in this area, what would you need to control for energy sources in here? So think about that as you're watching this. And then I will tell you my list here. Alright. So what did we just see going on here? One big obvious one. We've got a robot motion. We need to be able to lock that out and control it. You can't really tell by watching this, but there is heat going on in here. Those parts that are coming in there are still very, very hot. Those were liquid aluminum about 10 minutes prior to being cut. So those are still somewhere in the range of about 300 degrees, I think Fahrenheit. Okay, so it's still very hot. So you need to be able to control those. Basically, if you're going to be working in there, there's a lot of hot things in there you need to be careful of. those doors and the grippers on the robot are all pneumatic, which is compressed air. You need to be able to lock out that, control those sources of compressed air. And one big monster thing in there is a saw. We call that is a source of rotational energy. Even if you shut that saw off, it takes about 60 seconds for that thing to stop. So you need to wait about 60 seconds for that thing to come to a complete stop. So that is a source of rotational energy. Okay? So we've got a robot, we've got heat, we've got pneumatic, and we've got the rotating saw blade in there. So a lot of things to control in there. So during the servicing and maintenance of machines and equipment, the unexpected startup or release of stored energy can result in serious injury or death. When non-routine activities such as maintenance, repair, setup, or removal of jams, clogs, or misaligned feeds must be removed or defeat access to the machine, this is when we would need to be doing the lockout. So exceptions to these. You do not need to lock out if you are making a minor adjustment or service activity during normal production. So anything outside the guarding and it's routine, repetitive, or integral to production, these would be exceptions. To lockout, tag out rules. You probably do not need to lock out for these, but this would be defined by the facility that you're working in. Lots of different standards apply to these. So how do you know what to do for a lockout? Like, where is this defined for you? So an example of this is actually in our lab. So this is the 1028 robot lab on campus. All of our robot cells, if you see this here, this is called a lockout placard. I think it's spelled like that's placard. And what is on there is the procedure for locking out those robot cells. So any machine that you have should have one of these on it. What this contains, first of all, a diagram of the machine. So this is basically a map of all the cells. So this is your robot cage. This is the 4 individual robot cages. Okay. And then the bigger robot cage all around that. A little thing that shows you where you are. And then all of these things here, this is where it says E1, E2, E3, E4, P, and E. Show you what these are. This one here, this big red E, this one here, that is the main electrical. This would shut down electrical for the entire cell. These ones here, like these are called secondary electrical. This shuts down this cell only. Okay? So you can shut down here to shut down everything. You can turn off just an individual one to shut down just the individual cell. And then this one here. This one here, the P, that is the main air for main pneumatic. That is where you would lock out the air for the entire cell. Now right below that, there's some information here. It lists what that energy source is. it gives you the location of it, a very descriptive location. So on the side of the main control panel or back of the cell on the fence. So it tells you exactly where to find that, and you should see this symbol beside the device you're trying to lock out. How do you actually lock it out? For this one here, close the pneumatic valve slowly, attach multiple lockout device, lock and tag. Gives you an exact description. And then how do you verify it? Basically, how do you know that what you did was effective? Visually confirm lockout valve is in closed position and confirm zero pressure. Okay? For the electrical ones, you basically try to attempt to restart the system, and the system must not restart when you try that. Okay, so there are three parties that all have a responsibility as far as lockout go. Basically, we have management. They are responsible for reviewing, identifying employees, providing protective equipment, and monitoring performance of your lockout program. Supervisors have different responsibilities. Distributing protective equipment, ensuring procedures are established for machines, ensuring proper training has taken place, and employees under their supervision are following procedures. And then employees are responsible for assisting in the development of procedures, following these procedures, and reporting any problems associated. But very important that basically everyone is responsible. So lockout is no joke. Remember that. It is a very serious thing, and people take it very seriously. We'll get into some stories about that a little bit later. Some definitions. We're going to talk about disconnect switches, circuit breakers, affected employees, authorized employees, stuff like that. What is a disconnect switch? This is a disconnect switch. A disconnect switch, basically an electrical device that typically allows you to break three-phase power and is lockable. So you can put a lock right through here, like you can see being done right there. These come in, this is we'll call this a flange mounted. Because the device is kind of on the flange out here. This is a rotary style, so this works by basically turning it like that. Once you do that, you can put a lock through it, like right there. Circuit breakers. This is a magnetic device that works like a fuse, but it's a current limiting device, operates off of a magnetic principle. But when you flip these down, you can actually install a locking device on them like this. So in a circuit breaker panel, you're able to actually individually flip off a circuit breaker and lock it out. This is how that actually works. And then you can get all kinds of different fancy stuff. So you could have lockout stations like this in a plant where there are tags, hasps for multiple lockout devices, and lots of individual locks. That could be one way you do that. So there's basically 8 steps we're going to follow. It's an 8-step process to perform lockout. Step number 1, prepare and notify. So you're going to prepare the area and let people know that you're going to be locking something out. So you're going to tell them what machine you are locking out, why it's being done, how long it's going to be off for, and who is going to be responsible for this procedure. Step number 2, shut down the equipment. Make sure you do this in an organized way and follow the instructions. So if you have a robot that picks up parts and it is holding a part, you don't want to have that basically holding a part in the air when you shut it down and lock it out. You want to make sure everything has completed a cycle, is back to its home position, or is back to some type of maintenance position, and is a good in a good spot for when you shut it down. You want to make sure things are in a good spot that you can actually work on them if that's what you're trying to do, because remember, when you do this, you're actually removing power. So if it's something where you need it powered to actually be able to move it, you want to make sure that once you lock everything out, you don't need to move the machine again to get it into a position where you can work on it, because you can't do that at that point. So that is step number 2. Number 3, isolate any hazardous energy. So turn off all your disconnects, shut off all the pneumatic valves, things like that. Control gravity wherever you need to, so if there's things that are in the air, put your blocks underneath them. So do all these things, basically doing all those devices like that. And then dissipate and verify. So you're going to verify things. So how do we do that? Electrical, use your voltmeter. Verify you don't see any voltage anymore. Pneumatic and hydraulic, you should be able to look at gauges, see that you're reading 0 pressure. Mechanical or gravity, make sure all those pins are in place. Chemical, you're going to bleed off lines. So make sure all that is on, and then apply your lockout devices. So this is where you put all your locks on. Make sure each lock has its own key, and there is 1 lock per worker that's going to be working on the system. Okay, that is our rules. Then once you do that, we're going to go back, we're going to try to verify again. You're basically going to repeat step 4. So verify again. If all that checks out, then you're going to perform the work. And then after your work is all done, it could be 10 minutes. It could be 6 months, who knows, right? Depending on how big of the job is. After this is all done, you are going to go back, remove all those lockout devices. Inspect the area, make sure there is not a bunch of wires hanging, make sure all your parts and tools and people are out of the area. And then you're going to go around, remove all those lockout devices, notify people that we are removing devices and we're going to re-energize the system. And then we are good to go. Okay, so that is our procedure. So some key points about these things. Locks should be a safety lock, should be tamper-proof and only have 1 key. You can buy these at a safety store. You will need one of these for 2nd year. Okay, when we do our robot class, you will need a safety lock. So that is ERT107 Robots 2 class. You will need that. You must be in possession of this key at all times. That stays on your body. You're the only one that's in possession of that. And your lock must be identifiable as to who owns it. Okay? So let's look at some examples here. What is wrong with this picture? This is, I took this picture during a lab 2 years ago. What's wrong with this picture right here? Anyone guess? So here is our problem here. What's going on right here? This guy left his keys hanging in the lock. Now we said that you need to be in possession of the key. This guy is not. He is over here. And I can tell you when I saw this, I went over and I pulled the key out. And then I asked him where his keys were. And he looked all around for a couple minutes trying to find his keys. And then after that, I gave them back to him and said, do not leave your keys in the lock. Okay? Because basically if he leaves this in here, I can come over, remove this lock, close the door, and start the robot with him in there. Okay, and that's basically defeating the whole purpose of this. Okay, remember all your info goes on the lock. So typically, there's two ways you can do this. Number one, why do we call it tag out? Because we put one of these tags with our lock. We just put the lock just goes right through this hole here. And this has all your information on it. This has your name, your company, and your phone number. Because if you leave this lock on there, they want to be able to call you, and they will call you if they need to remove it and you are not there. They are not allowed to remove that lock without you there unless they have verified where you are, so they must be able to call you. So if it is 3 in the morning and they need to remove a lock and you are not present, they will call you. Okay, that is the rule. That is the security rule for this. Another way to do this without the tag is a lot of people or companies will have all that information, including a picture right on the lock, which is very nice. Make it easy to tell who it is. So you can see, if I want to know who locked out this, I can go over, I can just read this tag here. Only one lock per person working on a piece of equipment. So if there's 3 people working on a machine, there needs to be 3 individual locks. So here's a question. How many people are working in this robot cell? Can you tell? Correct answer. If we look down here, there are 3 locks. There's the reason there's 3 locks. There's basically 2 students, and then if the instructor were to walk in here, they need to have a lock on there as well, so they basically just put a lock on each cell. So there is always an instructor lock on here as well. So we can have 3 people inside that cell because there are 3 locks on there. Remember, remove your lock when you leave. Most places will have a very complex security procedure for removing locks. You do not want to be leaving your lock on and have security calling you. That's very bad. They don't like doing that. Okay. At St. Clair, we do not have a complicated procedure for this. On our machines, we have a little robot cell that is about 4 feet by 4 feet wide. It's very easy for us to tell if there is someone standing right there or not. It's not difficult to verify if there's someone inside that cell or not. So this is our method for removing locks. We call this the master key. Okay, that is how we remove locks. Here is a bigger problem. Is there anyone in this machine? Can you tell? No, you can't tell. This is about the size of an apartment building. Okay, this is a transfer press. This is a gear transfer press. I've done a lot of work on machines like this. You could be shut down for 6 months working on a project like this. There could be 100 different contractors working on this project. You don't even know half the people that are working on this. So when it comes time to re-energize this machine, and there's 100 different locks on here, and you take all the locks off and there's still 10 that are on there, and you don't even know the people, that there's pictures on the locks, and no one even knows who these people are, you can't remove those locks without verifying that they are not somewhere in this machine. This is a very complicated machine too, but you need to verify the location of all those people who locked that machine out. And they could have stopped working for that company a month ago and just never came back, but you need to be able to verify all that before you're allowed to re-energize that machine, because they could be in there, they could have passed out and are passed out 2 days ago and are trapped somewhere inside there. You don't know any of this stuff, right? So you can't restart that machine until you verify all of these things. Okay, so this is why we have to tag out everything and keep good accounting of where everybody's working. This is why we have all these procedures. So this is all taken extremely seriously by companies. Okay. So I will give you an example of this. So a couple years ago, about 2012, I was working in Bedford, Indiana on this machine here, which I showed you pictures of last week. And I was working I'll just stop this here. So you can basically see what's going on with this machine here. I was working on this, and what happened was people wanted the robot moved. Okay, so they wanted to put the robot end effector over here. So okay, so basically these guys went into this cell. They wanted to look at this robot in that position over there that I marked. So this cell, not very big at all. So we've got basically a sliding door right here. And this area here is where they want to look. We've got a robot. It was parked over here. The robot controller, where the lockout point is right here. So this is what happened. So one guy, one GM employee, puts his lock on the robot controller, walks in, he goes in, and he's looking at this. A second guy from GM puts his lock on the robot controller, and he goes in and looks at it. So they're both standing in there, and I'm outside of the cell. So they're looking at it, and they're saying, you know what, we want to move this robot position. We'd like to move it a little bit in this direction over here. So they ask me, hey, can you move it just by a little bit? So I ask them, how much do you mean, and where do you want to put it? So they say, a little bit over here, can you look at it? So here's what I did. With this door open, I went to right about here. And I stood there in the doorway. Mostly through the doorway. I think I still might have had 1 foot outside the door, but most of my body in the robot cell. There was already 2 locks on this robot controller right now. There is no way this robot can move. What happens? Somebody is walking by out here. They see me doing this, and they went and told their boss that they saw this guy inside a robot controller, inside a robot cell, without putting a lock on the robot controller. Okay, so that is by definition a violation of the lockout rules. This is in a GM plant where they are very crazy about their lockout rules and take it extremely seriously. So I was a contractor on this project. So what happens is the plant manager comes over and talks to me and basically says, you have violated lockout rules and you are now out of this plant for 3 days. So I had to go back to the hotel and basically wait in my hotel room for 3 days before I was allowed back in this plant. Now, I was the only contractor from my company working on this project, and no progress was made on this machine, which was already behind schedule. No progress was made on this for 3 days because I wasn't there. And the reason for why I wasn't there is because I went into a robot cell where I basically put 1 foot through the door, got most of my body through the door, not even all of it, into a robot cell that already had 2 locks on it, that was right behind me, maybe about 4 feet away from where I'm standing, where the locks are. I did not put a 3rd lock on there when there was already 2 locks on it. I did not do that. And by doing that, I had broken the rules and was removed from the plant. Okay, so people take these very, very seriously. Okay, so that is my lockout story to tell you. So be careful. If I wasn't critical to this project, I would probably have been removed from the project completely. Okay? So that is my lockout story for you. Are there any questions about this? We will discuss them on Friday.